Welcome. Today we're going to be talking about mixtures. What is a mixture? Well, you know that mixtures are different than substances. So mixtures are formed when you have two or more substances placed in the same container. Remember what a substance is. A substance is an element or a compound. So mixtures are two or more of those placed in the same container. Each substance in the mixture will keep its own set of properties, and you don't form anything new. They're just sharing the same space. They're getting mixed together, for lack of a better word. They are not chemically bonding into anything brand new. To separate a mixture, you will use a physical process, not a chemical reaction. So again, because chemical bonds were not formed when a mixture was made, you don't need to use a chemical reaction to break those bonds. They're just, particles are evenly distributed or mixed together in some kind of way, and there are procedures that we can use to get rid of them. So here are some different separation methods that you can use. The first would be boiling. So, for example, if you had salt and water and you wanted to get that salt recovered very quickly, you could put it on a hot plate or over a Bunsen burner would be underneath it, and then you could boil it. But traditionally, we don't have those kinds of tools. We could use the sun's energy to evaporate, and so that's a procedure where you've got lots of time. This shows just evaporating some sea salt. These folks are using that. So I just need you to know that boiling is what we call an active process, which means you have to add energy actively, and evaporation is what we call a passive process because it's just happening on its own. So a centrifuge, and I actually did find a graphic about centrifuge, is when you take a substance, and many times a centrifuge is used for blood, and you put it in a small container, and it spins the sample, and it's able to separate out the components of your mixture by density. So when you use a centrifuge to separate out the blood components, things like, blood cells and platelets and plasma, they use density. It spins very, very quickly, and then your test tube is separated out. The most dense things on the bottom, the less dense things towards the top. Distillation. Okay, so this is a small lab setup, but this can be done on a large scale. So in this first beaker, or the round bottom flask, you'd have a mixture, and it would be over a heat source. And so whatever's in here is going to get boiled. So you're going to have gases going up. And as they go up, they're getting further and further away from the actual flame. And so if you remember anything, once those gases are cooled, they're going to condense, meaning become a liquid again, travel down here and recollect over here where it is purified. So any contaminants would be left here, samples down here, and your new sample, still liquid, would be over here purified. I know with certain alcohols like vodka, they say, oh, this is triple distilled. Well, think about it. The more your substance is undergoing distillation process, the more and more pure it would get, because any of those impurities would be left behind in this first beaker, or flask, round bottom flask. Think about when you're making pasta. You have a pot of water that's hot. You put your pasta into that water, and when your pasta is done cooking, you need to remove the water. So you can use a strainer or a filter. If you want to get fancy, this is known as a colander. That's a C, colander. Make sure you know that with a strainer or a filter, or a colander in this case, you would have to have fairly large particles. So if you remember like the gold rush, all those old miners going out into the stream, they would use sieves to pan for gold. And so any gold would be large enough to stay in the filter, and any smaller particles or the water would go through. But again, those are large particles we're looking for. Okay, here's something called decanting. So you have something in this graduated flask here, and you place a stirring rod against the mouth. And because water has adhesive and cohesive properties, the water is going to attract to this stirring rod and kind of swivel down and then collect here. And any contaminants you would have would remain in that original flask or beaker. Magnets. Obviously, magnets are going to work if you have something that is magnetic you want to remove, something like iron filings. If you've ever played with an Etch-a-Sketch or one of those woolly willies, those faces where you have the small magnetic stick and you make a beard or mustache or hair, those are iron filings, and a magnet is able to attract those. So if you were to mix iron filings with sand or other particles that are really, really small, a magnet would be a great way to just remove your iron filings. Chromatography, hopefully a process that you've learned about in earlier science classes. So remember, chroma, meaning colors, the study of the colors. So what they do is you have a piece of filter paper, or coffee filter would work. Regular computer paper is not going to work. And you put a dot of dye. You put like a black marker or something. And you put it in what we call a solvent. So you could use either water as the solvent or you can use alcohol as the solvent. And what you can do is you can place that in there, and using capillary action, it will allow the dye to separate into its component colors. So this is not a measure of time. This is a measure of differences. And so we're going to talk about chromatography on the next slide. Chromatography is separation of a mixture based on two things, solubility and polarity. So solubility is something we briefly talked about. This is, will it dissolve or not? And polarity has to do with molecules, the molecule structures and interactions. So solubility, if and how well the substance will dissolve. Polarity has to do with molecular structures and attractions. So you see over here we have something called paper chromatography, which was on this last slide. There's the paper chromatography in the lower right. So you have your liquid solvent, sometimes water, sometimes alcohol. You have your ink dot, and using capillary action, it's going to flow up. Then we have something that you might see in a college lab or maybe an industrial lab, column chromatography. You have that's a little bit more in depth. We won't be getting to that in this class. Okay, thank you.